What's going on, community? My name is Gerald Moore Jr., and I am the president of Green Environmental Outreach, a 501(c)(3) nonprofit based in Ohio. Today, I'm going to just share with you some resources and information discussing climate change, discussing current topics when it comes to environmental justice, social justice, economics, opportunities, and things of that nature in America. As a 36-year-old African American that has been born and raised here, my family has been in America all my life. I've moved from the East Coast to the Midwest now, but my family grew up, down south. My grandmother's from the South, South Carolina. My grandfather's from Georgia, and we're still tracking a lot of our family history and our roots. But as a millennial and nonprofit leader, I think it's important that authenticity and truth is shared. And as somebody that currently lives in Ohio, which is a red state, and so overwhelmingly, folks have voted for the current president. And obviously, their initiatives are against some of the issues that we are seeking to combat in our country, especially when it comes to poverty, urbanization, rural issues, agriculture, food, access to quality, high quality produce in urban communities and rural communities, especially underserved communities. And so when it comes to a lot of these issues, they start at the federal government. Then they trickle down to the state government, then they trickle down to the county, and then local city. What? With that being said, please subscribe to our YouTube channel so I can bring you all more information. And so when we do release more information and resources, you guys will be notified. Also, comment. Let me know what country you're in, what city, what state. Also, your thoughts on environment. The environment. Obviously, we have these big tech companies. Obviously, in America, we're competing against other countries. China is the big one. And so, again, when it comes to capitalism, corporate America, sustainability, environmental justice, there are a lot of things at the intersection. We also cover cannabis and hemp, since those things are being newly legalized in our country. We do recognize that the hemp farm bill that was passed in 2018 legalized the agricultural production of hemp, which obviously has been illegal in the United States for well over 60 years. And the war on drugs has really harmed the African American community, in particular, African American men, Black, Brown, Latino, and Mexican communities. And it has caused a great harm to us as a community, as a society, as American whole, because it has ripped away men from families, young men, young boys from families. It destroyed a lot of families in many ways because the war on drugs basically essentially targeted African American communities and gave lots of funding from the federal government and state government to local police, where police, were known to target minority communities, African American communities, and people were getting locked up for mandatory minimums and long sentences for, small amounts of cannabis or weed, um, which obviously has had a major effect and impact on the African American community, America in general, and society in general. So, with the hemp farm bill being passed in 2018, this obviously opened up a bunch of avenues for agribusiness and agriculture. Cannabis and hemp isn't just for smoking or consuming for medicinal or recreational purposes. There are agricultural purposes and a plethora of other purposes for cannabis and the hemp, especially when it comes to the environment. So we will touch on some of those things on this channel. So again, I want to thank you all for finding us. I don't know how you found us, but thank you for finding us. Also, you can follow us on social media. We are on Instagram at GEO Nonprofit. You can go to our website to stay up to date. If you put your email in our website, we will be able to send you our newsletter. And we do typically update our blogs regularly, at least, once a month. And so our website is www.geononprofit.org. And again, we are a 501c3 nonprofit. And so we are able to accept donations if you support our mission, if you want to continue to see our mission grow and evolve. We do appreciate all the support that we can get as a grassroots 501c3 nonprofit. All donations are tax deductible, and there are a plethora of ways to donate. So again, thank you guys for all of the support. I'm going to switch over my screen and share my screen to just go over some resources and education. Oh, all right. So here we have the EPA.gov's website, and this is touching on climate change, the impacts of climate change. And so actually, let's go to the basics. And so this is something that we all can look up. As you can see, the United States Environmental Protection Agency. So the basics of climate change, learn about some of the key concepts related to climate change, the greenhouse effect, key greenhouse gases, other greenhouse gases, aerosols, climate feedbacks. So the Earth's climate is changing. Multiple lines of evidence show changes in our weather, oceans, and ecosystems, such as changing temperature and precipitation patterns, increases in ocean temperatures, sea levels, acidity, melting of glaciers and sea ice, changes in the frequency, intensity, and duration of extreme weather events, shifts in ecosystem characteristics like length of growing season and timing of flowering blooms, and migration of birds. These changes are due to a buildup of greenhouse gases in our atmosphere and the warming of the planet due to greenhouse gases. So here's a YouTube video. So the greenhouse effect, the Earth's temperature depends on the balance between energy entering and leaving the planet's system. When sunlight reaches the Earth's surface, it can either be reflected back into space or observed by the Earth. Incoming energy that is absorbed by the Earth warms the planet. Once absorbed, the planet releases some of the energy back into the atmosphere as heat, also called infrared radiation. Solar energy that is reflected back to space does not warm the Earth. Certain gases in the atmosphere absorb energy, slowing or preventing the loss of heat to space. Those gases are known as greenhouse gases. They act like a blanket, making the Earth warmer than it would otherwise be. This process, commonly known as the greenhouse effect, is natural and necessary to support life. However, the recent buildup of greenhouse gases in the atmosphere from human activities has changed the Earth's climate and resulted in dangerous effects to human health and welfare to the ecosystems. So here is a diagram, greenhouse gases. So it's showing you how some solar radiation is reflected by the Earth to the atmosphere. More radiation is absorbed by the Earth's surface to warm it. Obviously, you have Earth's surface, the atmosphere is in between that. And then you have infrared radiation is emitted by the Earth's surface. Some of the infrared radiation passes through the atmosphere. Some of it's absorbed and re-emitted in all directions by greenhouse gas molecules. The effect of this is to warm the Earth's surface and to lower atmosphere.
Did you know that gases in our atmosphere help control the Earth's temperature? Greenhouse gases, like carbon dioxide, trap heat in the atmosphere, and keep the Earth warm. This is called the greenhouse effect. It all starts with sunlight, which is a form of energy. Land and water absorb most of the sunlight that reaches the Earth. The rest is reflected back to space. The Earth's surface warms up, then gives off energy in a different form, called infrared radiation. This energy travels back towards outer space. Greenhouse gases trap some of this energy in the atmosphere before it can escape, making the Earth warmer. We need some greenhouse gases. Without them, our planet would be too cold for plants and animals to live. But people are adding extra carbon dioxide and other greenhouse gases to the atmosphere. Whenever we drive a car, use electricity, or make a product in a factory, we use energy. A lot of this energy comes from burning fossil fuels like oil, gas, and coal, which produces carbon dioxide. How do you think extra greenhouse gases affect the amount of heat trapped in the Earth's atmosphere? You guessed it. Extra greenhouse gases trap more heat, which makes the whole planet warmer. And warmer temperatures lead to effects like changing rain and snow patterns, rising sea level, melting glaciers and ice sheets, and much more. It's a big problem, and it's all happening because we are overloading the atmosphere with greenhouse gases. By making the greenhouse effect stronger, we're upsetting the Earth's natural balance and warming our planet.
So that was a great illustration, very simple illustration to show you obviously how humans are impacting climate change, obviously through production of goods, the clothes that we wear, plastics, cars, anything that's made in a factory, just like the video just showed. So again, it's up to us to be as responsible as possible, to be sustainable, to hold our politicians accountable, and as young people, you can hold your politicians accountable and the business leaders and your administrators and young adults as well. So obviously, this is a huge challenge that our country and society as a whole is facing. All right, so key greenhouse gases. Most of the warming since 1950 has been caused by human emissions of greenhouse gases. Greenhouse gases come from a variety of heavy activities, including burning fossil fuels for heat and energy, clearing forests, fertilizing crops, storing waste in landfills, raising livestock, and producing some kinds of industrial products. Carbon dioxide. Carbon dioxide is the primary greenhouse gas contributing to recent climate change. Carbon dioxide enters the atmosphere through burning fossil fuels, solid waste, trees, and other biological materials, and as a result of certain chemical reactions, such as cement manufacturing. Carbon dioxide is absorbed and emitted naturally as a part of the carbon cycle through plants and animal respiration, volcanic eruptions, and ocean atmosphere exchange. The carbon cycle. The carbon cycle is the process by which carbon continually moves from the atmosphere to the earth and then back to the atmosphere. On the earth, carbon is stored in rocks, sediments, and ocean in living organisms. Carbon is released back into the atmosphere when plants and animals die, as well as when fires burn, volcanoes erupt, and fossil fuels such as coal, natural gas, and oil are combusted. The carbon cycle ensures there is a balanced concentration of carbon in different reservoirs of the planet. But a change in the amount of carbon in one reservoir affects all of the others. Today, people are disturbing the carbon cycle by burning fossil fuels, which release large amounts of carbon dioxide into the atmosphere, and through land use changes that remove plants, which absorb carbon from this atmosphere. Here's another video on how carbon affects nearly everything on Earth. So that was another great example and simple illustration to show how we as humans, obviously, again, corporations, governments, and individuals are attributing to um, climate change. So methane, both natural and human activities produce methane. For example, natural wetlands, agricultural activities, and fossil fuel extraction and transport all emit methane. Nitrous oxide is produced mainly through agricultural activities and natural biological processes. Fossil fuel burning and industrial processes also create nitrous oxide. F gases, I'm not going to even pretend like I know these words.
Chlorofluorocarbons, hydrochlorofluorocarbons, hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride, together called F gases, are often used in coolants, foaming agents, fire extinguishers, solvents, pesticides, and aerosol propellants.
There you go. Other greenhouse gases, ground level ozone. Ground level ozone is created by a chemical reaction between emissions of nitrogen oxide, and volatile organic compounds from automobiles, power plants, and other industrial and commercial sources in the presence of sunlight. In addition to trapping heat, ground level ozone is a pollutant that can cause respiratory health problems and damage crops and ecosystems. Water vapor is another greenhouse gas and plays a key role in climate feedbacks because of its heat trapping ability. Warmer air holds more moisture than cooler air. Therefore, as greenhouse gas concentrations increase and global temperatures rise, the total amount of water vapor in the atmosphere also increases, further amplifying the warming effect. Aerosols in the atmosphere can affect climate. Aerosols are microscopic, solid or liquid particles that are so small that instead of quickly falling to the surface like larger particles, they remain suspended in the air for days to weeks. Human activities such as burning fossil fuels and biomass contribute to the emissions of these substances. Although some aerosols also come from natural sources such as volcanoes and marine plankton. Unlike greenhouse gases, the climate effect of aerosols vary depending on what they are made of and where they're emitted. Depending on their color and other factors, aerosols can either absorb or reflect sunlight. Aerosols that reflect sunlight, such as particles from volcanic eruptions or sulfur emissions from burning coal, have a cooling effect. Those that absorb sunlight, such as black carbon, a part of soot, have a warming effect. Not only can black carbon directly absorb incoming and reflected light, but it can also absorb infrared radiation. Black carbon can also be deposited on snow and ice, darkening the surface and thereby increasing the snow's absorption of sunlight and accelerating melt. For more information, see the 2015 report to Congress on black carbon. While reductions in all aerosols can lead to more warming, targeted reductions in black carbon emissions can reduce global warming. Warming and cooling aerosols can also interact with clouds, changing their ability to form and dissipate, and as well as their reflectivity and their precipitation rates. Clouds can contribute both to cooling by reflecting sunlight and warming by trapping ongoing heat. Climate feedbacks. Climate feedbacks are natural processes that respond to global warming by offsetting or further increasing changes in the climate system. Feedbacks that offset the change in climate are called negative feedbacks. Feedbacks that amplify changes are called positive feedbacks. Water vapor appears to cause the most important positive feedback. As the earth warms, the rate of evaporation and the amount of water vapor in the air both increase. Because water vapor is a greenhouse gas, this leads to further warming. The melting of the Arctic sea ice is another example of a positive climate feedback. As temperatures rise, sea ice retreats. The loss of ice exposes the underlying sea surface, which is darker and absorbs more sunlight than ice, increasing the total amount of warming. Less snow cover during warm winter has a similar effect. Clouds can have both warming and cooling effect on climate. They cool the planet by reflecting sunlight during the day, and then they warm the planet by slowing the escape of heat to space. This is most apparent at night, as cloudy nights are usually warmer than clear nights. Climate change can lead to changes in the coverage, altitude, and reflectivity of clouds. These changes can then either amplify positive feedback or dampen negative feedback, the original change. The net effect of these changes is likely to amplify or positive feedback due to mainly the increasing altitude of high clouds in the tropics, which makes them better able to trap heat, and reductions in coverage of lower level clouds in the mid latitudes, which reduces the amount of sunlight they reflect. The magnitude of this feedback is uncertain due to the complex nature of cloud-climate interactions. So that was a mouthful, but this is the United States Environmental Protection Agency. So causes of climate change. Since the Industrial Revolution, human activities have released large amounts of carbon dioxide and other greenhouse gases into the atmosphere, which has changed the Earth's climate. Natural processes such as changes in the sun's energy and volcanic eruptions also affect the Earth's climate. However, they do not explain the warming that we have observed over the last century. So here is a diagram, human and natural influences on global temperature. So you can see 1880, observed greenhouse gases is black, human drivers is red, natural drivers is blue, all drivers is that golden color. So you can see natural drivers is actually on the decline, observed and human drivers is exacerbated, going up. So human versus natural causes. Scientists have pieced together a record of the Earth's climate by analyzing a number of indirect measures of climate, such as ice cores, tree rings, glacier lengths, pollen remains, and ocean sediments, and by studying changes in the Earth's orbit around the sun. This record shows that the climate varies naturally over a wide range of timescales, but the variability does not explain the observed warming since 1950s. Rather, it is extremely likely that 95% that human activities have been the dominant cause of that warming. It is unequivocal that human influence has warmed the atmosphere, ocean, and land. Intergovernmental Panel on the Climate Change 2021 report. Greenhouse gases. Concentrations of the key greenhouse gases have all increased since the Industrial Revolution due to human activities. Carbon dioxide, methane, nitrous oxide concentrations are now more abundant in the Earth's atmosphere than any time in the last 800,000 years. These greenhouse gas emissions have increased the greenhouse effect and caused the Earth's surface temperature to rise. Burning fossil fuels changes the climate more than any other human activity. Carbon dioxide. In recent years, human activities have released around 35 billion tons of carbon dioxide into the atmosphere every year. Atmospheric carbon dioxide concentrations have increased by more than 40% since pre-industrial times, from approximately 280 parts per million, ppm, in the 18th century to 419 ppm in 2023. Methane. Human activities increased methane concentrations during the most of the 20th century to more than 2.5 times the pre-industrial level, from approximately 2022 parts per billion in the 18th century to 1,922 parts per billion in 2023. Nitrous oxide concentrations have risen approximately 20% since the start of the Industrial Revolution, with the relatively rapid increase toward the end of the 20th century. Nitrous oxide concentrations have increased from pre-industrial level of 270 ppb to 337 ppb in 2023. So here are some additional resources about greenhouse gases. Reflectivity or absorption of the sun's energy. Activities such as agriculture, road construction, and deforestation can change the reflectivity of the Earth's surface, leading to local warming or cooling. This effect is observed in heat islands, which are urban centers, which typically impact Black African American communities, minority and underserved communities, by the way, which are urban centers that are warmer than the surrounding, less populated areas. One reason that these areas are warmer is that buildings, pavement, and roofs tend to reflect less sunlight than natural surfaces. While deforestation can increase the Earth's reflectivity globally by replacing dark trees with lighter surfaces such as crops, the net effect of all land such as land use changes appears to be small cooling. Emissions of small particles known as aerosols into the air can also lead to reflection or absorption of the sun's energy. Many types of air pollutants undergo chemical reactions in the atmosphere to create aerosols. Overall, human-generated aerosols have a net cooling effect on the Earth. Natural processes. Natural processes are always influencing the Earth's climate and can explain climate changes prior to the Industrial Revolution in the 1700s. However, recent climate changes cannot be explained by natural causes alone. Changes in the Earth's orbit and rotation. Changes in the Earth's orbit and rotation, its axis of rotation, have had a big impact on climate in the past. For example, the amount of summer sunshine on the northern hemisphere, which is affected by changes in the planet's orbit, appears to be the primary cause of past cycles of ice ages, in which the Earth has experienced long periods of cold temperatures called ice ages, as well as shorter interglacial periods between ice ages of relatively warmer temperatures. At the coldest part of the last glacial period or ice age, the average global temperature was about 11 degrees Fahrenheit colder than it is today. At the peak of the last interglacial period, however, the average global temperature was at most 2 degrees Fahrenheit warmer than it is today. Variations in solar activity. Changes in the sun's energy output can affect the intensity of the sunlight that reaches the Earth's surface. While these changes can influence The Earth's climate, solar variations have played little role in climate change observed in recent decades. Satellites have been measuring the amount of energy the Earth receives from the sun since 1978. These measurements show no net increase in the sun's output, even as global surface temperatures have risen. So this is the global average surface temperature starting in 1980 to about 2015. Measurement of the sun's energy has seemed to fall a little bit. Changes in the Earth's reflectivity, the amount of sunlight that is absorbed or reflected by the planet depends on the Earth's surface and atmosphere. Dark objects in the surface, like the ocean, forest, and soil, tend to absorb more sunlight. Light color objects and surfaces like snow and clouds tend to reflect sunlight. About 70% of the sunlight that reaches the Earth is absorbed. Natural changes in the Earth's surface, like melting of sea ice, have contributed to climate change in the past, often acting as feedbacks to other processes. Volcanic activity. Volcanoes have played a noticeable role in the climate, and volcanic eruptions release large quantities of carbon dioxide into distant pasts. Some explosive volcano eruptions can throw particles, e.g., SO2, into the upper atmosphere where they can reflect enough sunlight back to space to cool the surface of the planet for several years. These particles are an example of cooling aerosols. Volcanic particles from a single eruption do not produce long-term climate change because they remain in the atmosphere for a much shorter time than greenhouse gases. In addition, human activities emit more than 100 times as much carbon dioxide as volcanoes each year. Changes in naturally occurring carbon dioxide concentrations. Over the last several 100,000 years, carbon dioxide levels varied in tandem with the glacial cycles. During warm interglacial periods, carbon dioxide levels were higher. During cool glacial periods, carbon dioxide levels were lower. The heating or cooling of the Earth's surface and oceans can cause changes in the natural sources and sinks of these gases, and thus change greenhouse gas concentrations in the atmosphere. These concentrations have acted as a positive climate feedback, amplifying the temperature changes caused by long-term shifts in the Earth's orbit. So I know this is a lot to digest, but if you have to stop it, pause it, take notes, do what you got to do. But I just want to upload this for our YouTube page. Again, please like, comment, and subscribe to the GEO Nonprofit page. Also, please, if you feel led to, donate to the mission. GEO Green Environmental Outreach is a grassroots 501c3 nonprofit. So all donations are tax deductible. And this is a grassroots nonprofit. So we are starting from scratch. We've been around for about 4 to 5 years. Our main goal is education and environmental and sustainability. But also we do projects, we do community gardens where we educate the community on environmental hazards, climate change, but also growing food in urban communities and trying to eradicate heat islands in our communities by getting rid of vacant properties that aren't producing anything healthy in our urban communities, whether it's blighted or lacking housing or parks. So we are part of P3, People, Parks, and Power. With climate change, also we have been advocates of hemp and cannabis because we understand that hemp grows faster than trees grow, and hemp can help soak up some of that carbon dioxide that I've been talking about and some of those greenhouse gases. Cannabis and hemp can also soak up some of the bad things in our soil and our air to help clean the soil and air. And again, this is still something new in terms of legalization inside America. So we have to educate everybody, our older generation, our politicians, our business leaders, our farmers, our youth, because again, this is the next generation of where we have to go if we want to protect our children and future generations. So impacts of climate change. Climate change is happening. Global average temperatures has increased by 1.7 degrees from 1970 to 2023. Changes of 1 or 2 degrees in the average temperature of the planet can cause potentially dangerous shifts in climate and weather. These real observable changes are what we call climate change impacts because they are visible ways that climate change is affecting the earth. For example, many places have experienced changes in rainfall, resulting in more floods, droughts, or intense rain, as well as more frequent and severe heat waves. The planet's oceans and glaciers have also experienced changes. Oceans are warming and becoming more acidic, ice caps are melting, and sea level is rising. As these and other changes become more pronounced in the coming decades, they will likely present challenges to our society and our environment. More on climate change impacts. Climate change is happening globally, but the effects can differ locally. Certain sectors, regions, and human populations are more vulnerable or have unique risks due to climate change. See the impacts. So warmer temperatures increase frequency, intensity, and duration of heat waves, which can pose health risks, particularly to young children and the elderly. Climate change can also impact human health by worsening air and water quality, increasing the spread of certain diseases, and altering the frequency or intensity of extreme weather events. Rising sea level threatens coastal communities and ecosystems. Changes in the patterns and amount of rainfall, as well as changes in timing and the amount of stream flow, can affect water supply and water quality and the production of hydroelectricity. Changing ecosystems influences geographic ranges of many plants and animal species and the timing of their life cycle events, such as migration and reproduction. Increases in the frequency and intensity of extreme weather events, such as heat waves, droughts, and floods, can increase losses to property, causing costly disruption to society and reduce the affordability of insurance. Looking ahead, elevated concentrations of carbon dioxide will persist in the atmosphere for hundreds of or thousands of years, so the Earth will continue to warm in the continuing decades. The warmer it gets, the greater the risk for more severe changes to the climate in the Earth's system. Although it's difficult to predict the exact impacts of climate change, what's clear is that the climate we are accustomed to is no longer a reliable guide for what to expect in the future. Adapting to climate change. Adaptation helps us prepare for some of the likely effects of climate change by reducing their impacts on ecosystems and people's well-being. Examples of adaptation include strengthening water conservation programs, upgrading stormwater systems, developing early warning systems for extreme heat events, and preparing for stronger storms through better emergency preparation and response strategies. Future of climate change. Since the Industrial Revolution, human activities have released large amounts of carbon dioxide and other greenhouse gases into the atmosphere, which has changed the Earth's climate. We already read all that. So while climate change is happening on a global scale, the impacts are felt locally in our neighborhoods, workplaces, and communities. You can learn more about these impacts in the interactive graphic by clicking on the magnifying glasses. So snow. Warming winter temperatures influence the amount of snow that falls and accumulates, the amount of seasonal snowpack, and the timing of the snowmelt runoff. Warming temperatures mean more precipitation will fall as rain rather than snow, and the snow that does accumulate will melt earlier in the season. This reduction in snowpack will pose major challenges for communities that depend on snowfall as water source, including many areas in the western United States. So drought, changes in the future precipitation and temperature are expected to continue to make droughts more intense in many parts of the country, especially the Southwest. Droughts can reduce agriculture yields and place strain on water systems. So we're here in Ohio, and a lot of people in Ohio, tend to think that we're not going to be impacted because we're inside. but that's not true. We have been going through a drought lately in the state of Ohio. And Ohio is a large agricultural state, producing corn, soybeans, and animals. Invasive species. Warmer temperatures makes it easier for some non-native species to spread to new areas, which can displace native species and disrupt ecosystems. Warmer temperatures have allowed certain insects and pests to expand their range and devastate forest ecosystems. Then you have coastal hazards. Sea levels rise and changing storm patterns are expected to increase the duration, depth, and frequency of areas affected by coastal flooding and erosion. Flooding threatens human health and safety in annually storm events, and chronic flooding causes billions of dollars in damages. Flooding can also disrupt transportation, making it more difficult to access healthcare, education, and other services. Flooding can also overwhelm stormwater and sewage systems and undermine water quality by introducing pollutants and disease-carrying organisms into water bodies. Marine ecosystems. The Earth's oceans will continue to get warmer and more acidic. Warmer waters are disrupting seasonal patterns for many of marine species and causing some of the shifts their ranges northward to cooler waters. Species that cannot move or adapt to colder waters have been negatively affected. Corals and other organisms that build shells will also continue to be impacted by more acidic water. These dual changes threaten the ability of coral to provide habitat for many fish species. Because of these factors, climate change is expected to reduce catches in the fisheries across the country. Air quality. Climate change will make air quality worse in many parts of the United States. Warm, sunny days speed up the chemical reactions that create ozone and can lead to higher levels than usual. Climate change is expected to make hot temperatures coupled with stagnant air conditions more common, which can concentrate air pollution. Poor air quality negatively affects human health by exacerbating asthma, respiratory disease, and heart disease. Children, older adults, and pregnant women and those with underlying heart or respiratory illnesses are particularly vulnerable to air pollutant impacts. Heat waves. Extreme multi-day heat waves are expected to occur more often and be more severe, affect more areas, and last longer. Exposure to extreme heat can cause severe heat illness and death. Children and people who work outside, older adults, and people with health conditions are particularly vulnerable to the impacts of heat. And so I'll go ahead and end it right there, and we'll pick up in another video. But I want to thank you guys for tuning in. Please like, comment, and subscribe to the GEO Nonprofit YouTube. Also, be sure to follow us on Instagram, TikTok, Facebook, and all other social media platforms. I am the president of Green Environmental Outreach, Gerald Moore Jr. Till next time, peace.